we are also developing, like many others, developing machine learning models on this data set. Okay. So a few months ago, so I got this email from the organizers of the platform for the UK Biobank. Right, so I would like you to actually read the email, but the key, I highlighted the key sentences here, right? So you're a part of the study of the UK Biobank, right? As you're aware, so the participants are actually free to withdraw their data from the UK Biobank at any time, right? So they're actually able to make requests that their data no longer be used in models, right? And in this particular moment, right? So there are some participants have decided that their data should no longer be used. Right. So this is not an isolated incident, right? So a little bit time after that, so I got another email, right? So there's another set of participants that wanted their data to be removed from the model. Okay, so what does this mean? So this means that so the models that I have already trained on this data set, and other people have already trained on this data set, right? So now we actually have an obligation to take those data out from those trained models. Right, so if I build a big neural network on this data set, as many people have, right, and figure out a way to actually delete the inputs of those individuals from that trained neural network. Okay, so I think this is a really interesting example because it illustrates a few key points I want to discuss. Right, so the first thing here is that the data itself is actually accessible and it's actually free to access. Right, so any people in this room, that you can actually, if you want to work with the data set, you can actually just apply for it and you'll be able to access the data. So the second point is that the same data set is actually being used to train many machine learning statistical models, right? Both by companies like Google, as well as by thousands of individual research groups. It's important to note here that actually the participants, the 500,000 people who participated in the study, actually gave their full consent for the full data set to be released. Right? So they said, okay, let's release the whole data set without adding noise, right? So, if you really want to attack the data, right, because you have the genotypes and you have all the lifestyle, behavioral information, I'm sure you could easily identify the individuals, but the individual, given that knowledge, said, okay, I will still give the consent. However, the individuals are at any time, right, can change their mind for any reason, right, both privacy and non-privacy reasons, to say, I don't want my data to be used anymore. So take it out from your models.
Yes. I'm trying to understand the problem. So if the data has been made public, what does it mean for somebody to change their mind? You can't undo that.
Right. So the data is public in a sense that if I want to do a study on a data set, I can request, and through a fairly simple process, have access to the data and work on the data set.
Okay.
Right. So it's not something that anyone can Google and download.
Okay.
And it's to researchers, it's not to anybody, correct?
So researchers are very broadly defined, right? So you can have biotech companies, pharma companies that are all working on the same data sets.
Okay.
Yes?
Are there limitations on releasing models?
No. So if if some researchers want to train their neural network or train logistic regression, they can actually release the full weights of the neural network on the GitHub.
And does it specify at all what obligation you have to then track down anyone who might have released might have used your released models?
If you want to do this deletion procedure.
Yeah, so
that's where it gets hairy, right? So that's where it's not clear how do we actually implement these deletions, both operationally, algorithmically, how do we delete data from the machine learning algorithm sufficiently, and then also how do we ensure that has been done.
What is a non-privacy reason for changing your mind?
Yes, there are many. So for example, I may not want my data to be used for studies of genetic risks of alcoholism, right? Not because I don't want my data to be used in any study, just because I don't want my data to be used for that kinds of studies, right? So people give a lot of reasons beyond privacy for why their data do not want to be used for particular studies.
So can you address this question without defining what use means?
I'm going to give a concrete mathematical definition of what the usage is. I just want to motivate the problem first. Okay, does the problem make sense to people? Right. So you have data, it's trained on a model, right? So now people have requests, I have to actually delete the data from that model. So we want to basically formalize that into a concrete problem. So where does this fit into the bigger landscape, right? So I think the example of UK Biobank illustrates a few interesting features, right? Since the theme of the workshop is on beyond privacy, I think it highlights a few other related questions, right? So certainly security and privacy of data is very important. For these individuals, for example, in the UK Biobank, for the participants, right? So these are important, but even more important is basically this notion of data governance, right? So they consented to have their data to be fully released and to be used in these studies, but they do want to have controls over this data, especially in the sense that they can say, I want my data to be deleted from this model or from these kinds of studies at any time that they want. Right. And I'll tell you why that's actually a very different technical question than privacy questions. Right. So basically for the talk today, I want to highlight, I think there's been actually a lot more work, technical work on the privacy area, but actually very little work about deletion and more broadly about data governance. So I want to give you a flavor of what are the technical questions involved and how do we formulate these problems for the computer science audience. Yes?
Ownership?
Yes, so there's also a lot of discussions about like who actually owns the data, right? So in the case of the UK Biobank, right? So it's not that when the participants participate in a study, the data is owned by the UK government or by the study organizers, right? So because if that's the case, then they're the ones who can decide who has access to the data, who can use the data or not, right? So the users, the participants still have some control over who actually can access and use the data because they can decide if they want to delete the data or not. Right. So data deletion, I think it's actually really fundamental component to this problem of data governance. Right, and then many of you also have heard about the right for data, right to be forgotten from the GDPR regulation, right? Which says that also individuals can have certain rights, in particular rights where they want to say that their individual personal data are to be erased, right, and no longer processed. Right, so I think that's also very much related to the question that we saw with the UK Biobank.
May I perhaps make two remarks on the GDPR? So in the consent article of the GDPR, it says very explicitly that if you withdraw your consent, the consent remains valid for the period that you had given it. My impression is that means that you could never ask that your data is removed from the model. You could probably, only looking at Article 7, say, I don't want my data to be shared anymore. There's something else in the GDPR. There is a very, very large research exception. It's exceptionally large and basically says that once data is used for scientific research, and that is again very broad, can also be in the private sector, it is assumed that the purpose is okay. And you could have as a legal ground legitimate interest of the data controller. So as far as Europe is concerned, I think this would not be an issue.
So that's a great comment. I want to, if there's time, I want to follow up that at the very end. I also just want to say that the case of the UK Biobank is actually quite different from what you said, right? So there are the explicit obligations that the data, once the data needs to be removed, right? If someone has trained a prediction or diagnosis algorithm that's using the data, right? There's some obligation to actually remove the data from the trained model.
On the basis of the GDPR, that's then what I would say. Yeah.
For GDPR, I think there's also discussion, debates about how exactly to interpret that, which I'll follow up later on. So, okay, so that's the motivation. That's how we actually started on this problem. So here are the sort of the technical considerations. Right. So as you know, many machine learning models, especially the more modern machine learning models, are actually quite good at remembering data. Right? There are also traces of information from the data sets, especially the training data is encoded in the algorithm. The obligations to be seen from the email that I got, right, from the UK Biobank actually asked for exact deletion. Right? So, so we actually really want to have some notion that we have exactly removed the individual from the models. The deletion request can occur in an online fashion. It can happen anytime, right? And all of these sort of, I think, make the problem quite interesting and difficult from a technical perspective. Right, so what I want to do here, and what the goal of our research agenda is to first, we want to formulate this problem, which to our knowledge has really not been done before. And then I'll tell you about some preliminary results that we have, but it's very much, I think, open for in terms of general solutions. Yes?
So I'm just wondering, are you going to compare it to just relearning on the...
Yes, I'll talk about that, yeah. Okay, so I'll go to the board and then show you the formulation of the problem, and then I'll come back and show you some experimental results we have.
You can erase that if you want.
Just in case there's still people who need it. Okay, so the set of the problem, right? So here's how we want to formulate the problem, right? So you're given a public data set. You have a data set. Right, so that's your data set, and you have some learning algorithm, right? So your learning algorithms, think of it as some algorithm, right, that takes your data set into a model, right? The model could be sort of a regression model. It could be unsupervised learning, so it could be both supervised or unsupervised. Right. So think of this model as corresponds to coming from some particular model class. So just as an example, right? So if your model is just running linear regression, right? So you take your data, you run linear regression, and you get the parameters, the weights of your linear regression. Or it could be the weights of your neural network. Okay, so it's a very simple generic model, right? So here's how we want to define deletion. Okay, so given I have some data set, and then my algorithm. Okay, so what we want to say is that, okay, so, and I want to delete the ith point from this data set, right? Make sure I get this notation correct, right? Delete I is a mapping that is from my data set, my current algorithm, at this point I, into a new model. Right. So this is just for a general way to say that, okay, so a deletion operation is just take as input my training data set, the model that I already have, and the point I want to remove, and just spits me back out like a new learning algorithm, right? A new classifier, a new regression model.
When you write A of D, you mean this is taking the algorithm into account or the outcome of applying A on D?
Yeah, so this is the learned model, right? Like the weights of my network. Okay, so it's a mapping, and such that so that the model that I return here after my deletion operation should be the same as the model that I trained if I never had this data point in the first place. Right. So if my learning algorithm is actually a randomized algorithm, which could be the case, right, then I would like this to be true sort of in distribution. But for simplicity, just think of it as a deterministic learning algorithm. I want to get the same algorithm back after I do my deletion operation. Yes?
This is just a terminological question. When you say data point, when I read your abstract, I thought it meant I'm still in the data set, but I don't want my gender, for example, to be included in the machine learning. Like I want to remove one field rather than like the whole line of
So
steps.
the email, I'll actually flash this back up again. So actually we can consider both scenarios, right? So here the actual email, this email says that this entire individual's data needs to be removed from anything, right? So all of the features need to be removed.
Yeah.
So we can also consider
So you
like
could
subsets.
figure out This method works for both of these scenarios.
We can consider both scenarios, right? But that's for now, just focus on, for simplicity, just focus on this case where I remove an individual.
So are you assuming that the algorithm A is known? Because in some sense, it's not clear what it means, what A of D sub minus I means, when all I've told you is what behavior A takes on D.
Right. So yeah. So I'll show you. So you can have different algorithms for learning this. Right. So I'll show you some examples. But all that for the deletion to make sense, all that it says that is doesn't matter how you reach this algorithm. Right. The end result has to be the same as if I've never seen this data point in the first place.
I guess I mean for an outside observer, what does it mean for the algorithm's behavior to be the same as what it would have been? An outside observer who doesn't have access to the algorithm doesn't know. So is there some accuracy, some notion of accuracy of the algorithm in your?
Well, so there should be the same in terms of the. If you think that it's the parameters of the algorithm should be exactly the same, right? So if you have a deterministic algorithm, right, linear regression,
So
straight.
A is actually fixed somehow.
Or at
Yes.
least this similarity, these should be indistinguishable even to an observer who knows a complete description of A. That's fair.
Okay, good. Yeah, that's,
Remove an algorithm can
So let me actually push down a little bit more in the interest of time, and then I'll take more questions after Cliff needed. Okay, so that's the deletion operation, right? So that's just the definition. I haven't told you anything yet, right? So the point here is that, so I want to make a couple of remarks, right? So first is that deletion, this problem of data deletion is really a computational problem. Right? And in contrast, I would say most of the questions around privacy is more statistical. So what does this mean? So this means that, so here I'm purely interested in efficient deletion algorithms, right? So any algorithm, I can achieve this deletion operation by simply retraining from scratch. Right? And it's what both say, so I can just retrain the algorithm from scratch. So clearly, in most cases, for neural networks in particular, that's actually really not feasible, right? So the algorithm question is, how do I actually achieve this efficiently given any learned model, right? So whereas the privacy questions, I think, is quite orthogonal, right? So you can have algorithms that are differentially private that do not support efficient deletions, and also vice versa. So I want to give a couple of examples of, yes?
Although if an algorithm is differentially private, you might argue that people wouldn't need to ask that their data be deleted in the same way.
Yeah.
Well, so differentially private algorithms do not support exact data deletion.
That's true,
Right.
but like,
So then we can get into arguments about, is that sufficient? But certainly not by the letter of these requests and emails.
there.
So I want to show you what are some examples of algorithms that are efficiently deletable, and what are the ingredients of how we can build up such algorithms. Can I actually just push down a bit more? So first example is actually, let's just look at linear regression as a warm-up case. Right. So I have y equals to x beta with some epsilon. Right. So here my model, the learning algorithm should somehow figure out beta. Right? You can do whatever your favorite ways to do it. Right. So, right. So the standard way to Okay, so if I want to delete a an individual, the ith individual data point from this data set, right? So the idea is how can we actually compute beta, the new beta hat with the ith individual deleted as quickly as possible, right? Without having to resolve this least squared problem. So it turns out that in this case, actually deletion is relatively easy, right? So if I want to delete the ith point, I can actually directly subtract it from here. The harder part is how do we actually do this part, right? And this I can actually also turns out to basically remove individuals and delete them in time of basically d squared. Right. So there's no dependence on n, which is crucial here. So n is the number of individuals I have. Right, so we want ideally deletion algorithms that are independent of the size of my data set.
Here you're saying what you store is both XX transpose and X transpose Y.
Yes.
So you're sort of changing what the definition of the model. Not changing it really, but you're saying you have to store extra information.
We can store extra, but the goal here is that during deletion time, have something that's independent of n. Right. And that's really the sort of the algorithmic goals. I want to find algorithms where I can delete in time that's independent of n, but maybe with some dependence on the dimensionality of the problem. Right. So the other kinds of problems, right, that you have seen already, where you can have explicit efficient deletion, are basically things like nearest neighbor kind of algorithms. Right? So like k-nearest neighbors, if I actually remove one of the nearest neighbors from my training data set, I can actually just basically forget about them. Right? So basically the ingredients that we were coming up with for efficient data deletion for algorithms that have this property are the follows. So it's one more example, just very quickly. So it turns out that for gradient descent-based algorithms, right, they're actually not efficiently deletable, right? So the idea there is that if you take some gradient descent, or even SGD, right? So if one of the particular gradients depends on a particular data point, then that information can propagate. It's actually very hard to unwind this data point, even if the problem is convex. Right? So we have lower bounds to show that you can't really do that. So what are things that are easy to work with? Right, so basically, if you have useful summary statistics, right, so in the linear regression case, you have useful summary statistics. If you have sort of non-parametric, or in some sense local algorithms, so k-nearest neighbor, or sort of kernel regression type methods are non-parametric. Right. So if you have sort of hierarchical models, right? So if somehow you have models that are using data sets in a hierarchical manner, right? I'll show you an example of that. If there's time, then you can delete things. And then the last part, maybe the most interesting part, is there are algorithms where you can efficiently check if an exact deletion would actually change the outcome or not, right? If deletion matters. So if you can do this, then we can actually do this efficiently. So in the last remaining 2 minutes, I'll actually just show you maybe at a high level of what we could do right now and what are the experimental results. Right? So basically and I want to just illustrate this in the case of unsupervised learning, so clustering problems. Right? So in clustering, let's even look at the simplest version, so k-means. Right, so I have a bunch of individuals. I want to cluster them into k groups. Right, so even there, we'll have to be a little bit careful how to design algorithms that are actually exactly deletable. Right. So there are basically two types of algorithms I wanted to talk about to illustrate the hierarchical notion and then the last notion of efficiently checkable. Right, so the idea of hierarchy for clustering is that if I basically split my data sets into different groups, right? If you imagine randomly splitting data points into these groups, and then if within each group compute some local k-means, right? Pass those clusters up in some hierarchical notion. Right? Then if I have to delete a particular data point, then I only have to change this particular path. Right, so the time basically somehow logarithmic rather than linear in the number of data points. And then very quickly for the efficient checkable version of hierarchical clustering is that basically we look at quantized clustering, where the idea there is it's an algorithm that we developed where the idea there is that instead of looking at assigning exact k-means to every iteration, right? Every step, every iteration of k-means, that's actually essentially quantize the centroids and then keep track of where the centroids are quantized to, right? Basically keep track of history of that, which enables us to efficiently check in real time if a data point comes along, did that actually change any of the trajectories of centroids? So basically experimentally, here is just showing various deletion experiments on top of real data sets, right? So if you actually just run real standard algorithms, right, versus running these quantized or hierarchical algorithms, you can actually get like 4 orders of magnitude improvements in the amortized deletion times, right? So if you actually really want to run these kind of algorithms on large data sets while still committing to the notion that you can give people governance and deleting their data when they request it, then I think we need to investigate more in these efficiently deletable algorithms. I'll stop here. Yes?
So I'm sure there'll be questions about like why you want to, so we'll come back to these earlier questions about why this is a problem to solve in a minute, but just at a technical level. Have you looked at the literature on history-independent data structures? Any connection with this?
I've looked at, we've seen some things along those lines, but maybe it's worth discussing more offline of are we looking at the same literature or not.
This came up in the context of sort of some cryptographic context.
Yeah.
So, not machine learning models.
Yeah.
Different kinds of data structures. Right? Like same tricks probably. The other question I had was about, so you're okay with linear space. You just want the time updates to be, like the running time of the updates to be fast. Is that correct? Is that correct?
That's right.
And does it matter if the size of your data structure and the complexity of, say, making decisions were to increase as you delete more and more points, or increase slowly, perhaps, hopefully?
Yeah, I mean, ultimately, we just want practical algorithms, right? So the current standard clustering algorithms or neural networks they're not practical for deleting data points, right? So whatever is practical, if I have like reasonable space, reasonable memory, reasonable complexity, I'm happy with those practical solutions.
So maybe one more question as our next speaker sets up. You have to pick which one.
Yeah, sure. Just, like, this is quite conceptual, so 2 things. Like one is, like if we think of it as being like a disclosed model, it's kind of like, yeah, okay, you can imagine trying to make some change here, but like if we had like a scientific finding, which was based on like the data that people disclose, like what does it mean to sort of like undo the publication of that scientific finding? And I wonder if like that is even relevant here. And then like sort of related question is, to the extent that we can think of differential privacy as sort of saying that like it doesn't really kind of matter whether or not you're in the data set, like, and I know I'm like hand waving here, but like if that's how we understand it, what does it also mean to say that someone really should have like a right to withdraw their data if the guarantee they're provided with differential privacy is like it doesn't matter that they're in the data set?
Yes, I think those are all great questions, right? So, and it's actually very early stages of discussion for any of these questions, right? So the point that we want to take is that the current commitment that are often required of researchers to delete individuals' data, right? This exact deletion is actually not practical, it's not feasible given our current algorithms, right? So even for that limited problem, right? So I think we already need to think about how to formulate the problem and how to come up with better algorithms. And then as you write, then there's the higher level questions about when is this actually going to achieve the desired outcomes. Right? So I agree that for specific scientific findings, if you find that this biomarker is related to breast cancer, you can't retract that paper, right? If people decide to withdraw their data. But if you have a predictive model that's taking information from 23andMe and predicts height or disease risks, right? And if some subset of individuals in 23andMe want to withdraw their data, you can imagine actually changing that predictive model.
But your premise is that the use, after the model's developed, you're continuing to, that the model is still using the data.
Yes.
Yeah, and I'm not sure that data protection law would view it that way. I think is part of what.
Well, from a machine learning perspective, right, so the model is certainly actually using the data. For example, if I have a k-nearest neighbor algorithm, I mean, it's explicitly using the data, right? I mean,
there's definitely more to this
the neural network is somehow obfuscating how data is being used.
But I think the question of what it means to use is really the kind of the link.
Yes. So we have a particular definition of that here.
Yeah, I think it's a great question, but more than a 1 minute discussion question. So let's save it and move on and say.
And then it's a question of whether you really remove this person or not, because you have the choice of other people to remove